Okay, 8th graders, today we're talking about geometric sequences, and can you use geometric sequences, sorry for the typo, can you use geometric sequences to describe patterns? So first we need to talk about what a geometric sequence is. In a geometric sequence, the ratio between consecutive terms is the same. And the common ratio is the ratio in a geometric sequence write the next three terms of the geometric sequence. So if we can figure out what's happening, times 2 times 2 times 2, we can write the next three terms. We would get 48, 96, and 192. Check. Yep, 192. Graph the geometric sequence 32, 16, 8, 4, 2. What do you notice? So to graph these, we can say that this is in the first position, second, third, fourth, and fifth. So we'll take this as our x value, and this is our y values. And if we count up by fours, we should be close. So 0, 32, 132, 216, 3, 8, 4, 2, and we notice that we have an exponential curve for a line. On the next set of problems, we have to write the next three terms of the geometric sequence and then graph it. So 1, 3, 9, 27, we are multiplying by 3. So we get 81, 243, and 729. So let's count up by, let's just do 5s. So 1, 1, 2, 3, 3, 9, 4, 27, and then 5 is 81. So again, we have an exponential curve. Here we're dividing by 4, so we would get 1/4 1/16 and 1/64. So if we again count by tens, one 64, 2 16, 3 4, 5 1, and on the last one, divide by -2, yeah, divide by -2, which would leave us with 5, -2.5, and 1.25. So we have 20, 40, we'll count by tens this time. 180, 2 -40, 320, 4 -10, 5 5, -2.5. So here we're gonna have this crazy curve that looks like the heartbeat line. Alright, so when we have a geometric sequence, we have numbers in different positions, 1 2 3 4, all the numbers up until whatever number we're going to end with. Our general rule will be here. So this is called the first term, and we write it as a to the 1. Second term, we write them all with subscripts. Third term, fourth term, and so on. And then we call this one the nth term. I'll write it as a subscript n. If we're using a subscript 1 and r, our first term will always look like this. Our second term is the first term times the common ratio. Our third term is the first term times the common ratio squared, common ratio cubed. So we get our first term times the common ratio to the n minus 1 power, because this is 1 less than this, 1 less, 1 less, and 1 less. So if our first term was 1, then we would have, and our common ratio was 5, we'd have 1 times 5, which is 5. If our common ratio was 5, our third term would be 1 times 5 squared, which is 25. Then we'd have 1 times 5 cubed, which is 125. Then down here we'd have 1 times 5 to the n minus 1 power. So our equation for a geometric sequence is what we just found over here. It's a to the subscript n, our first term times r to the n minus 1 power. So depending on the term, we just do the exponent to that number minus 1. So if we have a real-life application, clicking the zoom out button on a mapping website doubles the side length of the square map. Write an equation for the nth term of the geometric sequence. So if we click once, the side length is 5 miles. If we click twice, the side length is 10 miles. And if we click 3 times, the side length is 20 miles. So it doubles it each time. So our equation, since our first term is 5, and our common ratio is times 2, we double to the n minus 1 power, because we're not sure how many they want us to take it out. Now, the next question says find and interpret the 8th term of the geometric sequence. So we have a to the n equals 5 times 2 8th term, so subtract 1 would be 7. And if you type that into your calculator, you get 640. So the interpretation would be that after 8 clicks, the map is 640 miles on each side. After how many clicks on the zoom out button is the length of the map 2,560 miles? Well, we know our equation is 5 times 2 to the n minus 1 power. And if we're trying to figure out 2,560, we'll fill it in. We'll divide by 5. And we get 512. And then to figure out what goes in here to get 512, I would just do a guess and check. I did 2 to the 10th, which was 1,024, so 2 to the 9th would be 512. So 9 would be 10 minus 1, so 10 clicks. Okay, I have some problems for you to practice. Find the common ratio for each one. What is it being multiplied by? Write the next 3 terms in graph. Tell whether it's arithmetic, geometric, or neither. And then number 9, in art class you're creating a design that uses 1 glass bead in the first row, 3 in the second, 9 in the third. Describe the pattern, write the next 3 terms, and is it arithmetic, geometric, or neither? Have a great night.